Okay, join me on the Math on the Spot video. Use your scratch paper to follow along. Take initiative. Pay close attention.
I got the sunblock on. I'm going to put on my sunglasses. I've got my noodle for swimming. And oh, hi! Hey, I was actually about to go to the beach to watch this really exciting competition of building sandcastles. You know, when they actually do sandcastle building competitively, they just don't use sand. They actually use some percentage of sand, and then they use some flour, and then some water, and they mix them all together, and they make these really amazing sandcastles. In fact, three of the teams that I already know, Team A, B, and C, they've already figured out the percentage of sand they use in their mixture. In fact, check it out. I can even show it to you real fast. So Team A actually has 75% sand in their mixture. Team B has 95% sand in their mixture. And Team C has 84% sand in their mixture. I was actually going to go down and check them out. Of course, I was going to bring my Frisbee and noodle just in case I was going to have some fun. But actually, you know what? Before I take off, why don't we have some fun doing a math problem together? I've got a math riddle, in fact, that's going to be right up your alley, because it's about Team D. Now, I know about A, B, and C, but Team D just joined, and I don't know much about them. Here's all I know. Team D used a recipe that consists of 20 cups of sand, 2 cups of flour, and 3 cups of water. And the question is, how does the percentage of sand in Team D's recipe compare to that of these other teams, my friends, the teams that I already know? Well, let's think about it together. So we want to actually figure out a percentage. Now remember, here's the recipe that Team D used. They said, we're going to use 20 cups sand, 2 cups flour, and 3 cups water. And I want to know the percentage of sand used in this mixture. So I want to know what part is 20 to the entirety. Well, that's a ratio. You see, isn't this great? This is great. Even on the beach, we see ratios. So what's the ratio? It's this part to the whole. And so what would that mean? It would mean that we'd be looking at, and in fact, we have to use sand color. We'd be looking at, well, this is the part, so 20 is the part, to the whole. And what's the whole? Well, it's all the material used, all the stuff. So all the sand, all the flour, and all the water. So that's going to be 20 cups plus 2 cups plus 3 cups. That's the entirety. And 20 cups is the part of all of that that represents the sand. And this is the total. So this is part to the whole, and that's the ratio we're looking at, which is 20 divided by 25. Now, I want to write that there was a percentage, just like my other friends have theirs, team represented their percentages in terms of sand. So I need this to be a percent. Now, remember, a percent is just a very, very special ratio where that bottom number, the denominator, is 100. So I've got to write this fraction, this ratio, as an equivalent ratio where, in fact, I have 100 downstairs. So I have to write this as an equivalent. Now remember, the way you write equivalent ratios is either multiplying or dividing both the numerator and the denominator by the same number. So the question is, what would I have to multiply 25 by in order to make it 100? 100 is the magic number for percentages. Well, 25 times 4 is 100, right? You know that. If you have 4 quarters, you have 100 pennies, or $1. So we multiply the numerator and denominator by 4, so it's actually really easy. And so 20 times 4 is 80, and 25 times 4 is 100. And so we actually see that this equals 80%. And so that actually tells us that Team D actually used 80% sand in their recipe. And now we can actually compare the 80% to all these other percents. Because remember, that's the question, to compare Team D's percentage of sand in their recipe with these. And so if we do that, here's what we see. We're going to compare all of these to 80%. And if we try it, here's what we see. we see that 80% is greater than 75%, but 80% is less than 95%, and 80% is less than 84%. So what that tells us is that the percentage of sand used by Team A was in fact greater than that used by the percentage of sand used by Team D, my team, Team D, is actually greater than that used by Team A because 80% is greater than 75. But for B and C, it's the other way around. It turns out it was less than the percentage used by B and C. So check out how cool it is that we're able to actually, by figuring out a percentage, actually compare different percentages of different parts of different recipes of different teams. Well, this is the great thing about percentages. No matter where you are, you build insights, even if you're at the beach. I'm actually going to run and take a look at those sandcastles. Come and join me if you want. In fact, let me practice my frisbee throwing right now by throwing this frisbee. Let's see how I do. Here we go. You ready? Here we go. Woo! Oops. I guess I shouldn't have done that. That was a mistake. But I still have the noodle. I certainly won't throw that. Oh, wait. Oh, no. This is not going well. Well, I'll see you soon. Have fun with math.
Thanks for watching. See you on the next one.